Welcome to training course, Digital Presentation, and Preservation of Europe Ritual Cuisine. Module 2 Basic Theory and Practice, Theoretical Basics of Photography. The basic element of photography, types of sensors, format and resolution. This lesson aims to provide students with the basic notions and concepts regarding types of sensors, format, resolution. At the end of the lesson, students will know how sensors work, what types of sensors are on the market and how to distinguish them. They will know their formats and their resolution, plus they will know the concept of ISO value. The procedures for obtaining a photograph are the same whether we are using an analog camera with film or a digital camera that has a sensor instead of photographic film. The sensor of the digital camera is therefore one of the most important components of our device. The advantage of a digital camera lies in the fact that we have a greater ease in the post-production of the image. A sensor is a silicon rectangle on which a whole series of photosensitive elements called photodiodes are implanted, which are very small in size. We are in the order of microns. The photodiodes are arranged in a series of rows and columns. The number of rows and columns determines the resolution of the sensor. The photodiodes are square in shape. They record the amount of light and give rise to the pixels that make up the photographic image. The word pixel stands for picture element. However, the photodiodes record only the light but not the color of the image we are photographing. To register the color, each photodiode is intended to register a color, red, green or blue, or the primary colors. This happens thanks to the Bayer filter placed above the photodiodes. When the light, filtered by the Bayer filter, hits the photodiodes, the sensors applies a process called demosaic, thanks to which the primary colors are mixed and reproduce the real color of the photographed object. This is a very complex process, and there can often be miscalculations. We have seen that a sensor is made from a large silicon disc. The larger the sensor, the less it can be made, and therefore a large sensor will cost more than a small sensor. We have said that the photodiodes and therefore the pixels make up the photographic image. The larger the pixels, the more quality we will have. Having a large sensor means having larger and more pixels. We can therefore find different sensor formats on the market. Typical sizes can be very small and range from 1 by 1.7 inches, 1 by 1.8 inches up to 1 by 2.5 inches. Small sensor sizes are the 4/3, which measure 17.3 mm by 13 mm. These sensors are typical of compact cameras. They take pictures with a 4:3 ratio and are of good quality in bright light. The sensors with APS format, acronym for Advanced Photo System, have larger dimensions ranging between 22.2 mm by 14.8 mm and 23.6 mm and 15.7 mm, for APS-C sensors, C stand for Classic, and 28.7 mm by 19 mm for the sensor of class APS-H. H stands for High Definition. These sensors take photos with a ratio of 3:2 like 36 mm by 24 mm photographic film and are typical of amateur or semi-professional reflex cameras. The larger and therefore more preferred sensors are the full-frame format sensors. They are the same size as photographic film, which measures 36 mm by 24 mm. They have a ratio of 3:2. Have larger pixels and more in number than all other formats. This type of sensor is found in semi-professional cameras of excellent quality and in professional ones. A sensor is made up of a number of pixels that make up the photographed image. The larger the sensor, the more pixels we will find at our disposal, the more high quality the photograph will be. Even the pixels can be more or less large, A very large sensor with very small pixels will make very high quality photos. The resolution of the camera and image is measured in ppi, or pixel per inch, pixel per centimeter. Let's take an example, 4000 times 3000, the width and height of the sensor, results in 12 million pixels. If we divide this number by 1 million we reach the figure of 12 megapixels. That camera will have a 12 megapixels resolution. In the image we can see the summary sheet of the Canon 6D camera. This camera is a semi-professional reflex camera whose sensor belongs to the full-frame class, therefore the largest sensor available for reflex cameras. In fact, we can see that the sensor measurements are those corresponding to photographic films or 36 mm by 24 mm. The resolution of the images produced by this camera are 20.1 megapixels. In fact, the sensor captures images of 5472 pixels by 3648 pixels. Continuing to read the summary sheet, we can see the size of each pixel, a determining factor for the resolution of the image. Each pixel captured by this camera is 6.55 microns large. The aspect ratio of photos taken with this camera will be 3:2. If the sensor is the fundamental component to writing with light, it is important to introduce another fundamental concept directly related to the sensor, the ISO value. With our camera we can set the ISO value or the sensitivity of our sensor, which will try to collect as much light as possible, when the lighting conditions are difficult or bad. The ISO values start from 100 and double at each step, 200, 400, 800 etc. By increasing the ISO value, we ask our sensor to make more effort in capturing as much light as possible, but in doing so we also capture a greater number of irregular photons that will be read in the wrong color. This phenomenon is called noise. The more we use, the less qualities we will have. The course was created by the consortium of the Eurica project funded by the Erasmus Plus program. Thanks for the attention.